Ever wondered how real-time PCR works? Imagine an advanced version of polymerase chain reaction where scientists can witness DNA amplification in, well, real time. This isn't science fiction, it's real-time PCR. This technique ingeniously links DNA amplification to the generation of fluorescence, which is detected during each PCR cycle. It's like watching a live broadcast of DNA being copied right in front of your eyes. Now that you have a basic understanding, let's delve into the principle of real-time PCR. The principle of real-time PCR is quite simple, yet ingenious. It all begins with a DNA sample, a complex code that holds the secrets of life. This DNA is mixed with primers and nucleotides, the building blocks of DNA. Once combined, the magic happens. The concoction is heated, causing the DNA strands to separate, a process known as denaturation. When the temperature is lowered, the primers get a chance to attach to the DNA strands in a step called annealing. The primers serve as starting points for a new DNA strand. With the temperature raised again, the polymerase is activated, kickstarting the synthesis phase. Here, the polymerase zips along the DNA, adding nucleotides to form a new DNA strand. This entire process is known as amplification. But what makes real-time PCR stand out is its ability to measure this process as it happens. As the DNA copies increase, so does the fluorescence, a bright beacon in the microscopic world. This fluorescence is detected by a camera in the PCR machine, effectively monitoring the progress of the reaction in real time. So that's how real-time PCR works. It's a simple process, but it's a powerful tool in the hands of scientists. It's like having a front row seat to the most fundamental process of life, being able to see and measure DNA as it replicates right before your eyes. Let's summarize the key points about real-time PCR. This advanced form of PCR doesn't just amplify DNA, it allows scientists to observe this amplification as it happens in real time. It's like having a front row seat to the very essence of life itself. How does it do this, you ask? Through the magic of fluorescence. As the DNA multiplies, so does the fluorescence, giving a visual cue of the progress of the reaction. But it's not just about watching DNA multiply. Real-time PCR has profound implications for the study of gene expression. This technology gives scientists the power to measure and analyze changes in gene expression levels with exquisite precision. This is a game changer for scientific research, with applications spanning from diagnosing diseases to understanding how genes influence behavior. Real-time PCR is a fascinating technique that has revolutionized the field of molecular biology. Thanks for joining us on this journey into the world of real-time PCR.